Well, let's look at using the skills that we've learnt in this linear straight line graph unit and look at how we can apply those to some real life situations. So what we do know is that rules and graphs are really useful when we want to look at analysing the relationship between two variables. Now, graphs give us a really good visual Well, let's look at using our skills that we've learned during our topic of straight line graphs and applying them to some real life situations. No, that's 1, 2, 3. Well, let's look at applying our skills to some real life situations. What we do know is that rules and graphs are really useful when we want to analyse. Let's go back and start again. Well, let's look at using the skills that we have learned in our topic on straight line graphs to applying those skills to some real life situations. What we do know is that rules and graphs are really useful when we want to analyse situations that involve two or more variables. In order to transfer information from a worded question or maybe a situation that we may encounter in real life, we need to make sure that we read the information carefully and select what is relevant. One of the very first steps we can do is to define the variables. That is, we need to decide which pronumerals we wish to use and what will they represent. So things like V for volume, T for time, A for area, C for cost. Then we need to decide which one is the independent variable. That is, which one will go across the bottom on the x-axis and which one is the dependent variable that will go up the side on the y-axis. So generally speaking, time is normally an independent variable. It is usually the one that you change yourself. So you decide to change the time and then the dependent variable changes accordingly. Step number 2 would be to complete a table of values. So once you have a table of values, you can then graph them, you can then find the rule for them. So then when you want to graph, you draw up an appropriate set of axes. You need to think carefully about the scale. So you look at your table of values, you look at your rule, and you work out what scale is required. And then from either the table or from the graph, you want to find the rule. So you look for the gradient and you look for the y-intercept. Once you have a rule, you can then use that to find other solutions. So let's start with a practical problem on water storage. In this case, we're going to be using a tank. The volume of water in the tank starts at 1,000 litres, and then there's some constant rainfall and the volume of the water increases by 2,000 litres per hour for the next 5 hours. So what I have there is a few clues that I wish to use, but I want to make sure I know what the variables are. So time is one variable, and that's going to be my independent variable. So let us just make sure we write that down. Let t equals time, and I'm going to be measuring that in hours. And my other variable is that the volume is going to change as the time changes. So my second variable is volume, and I'm going to measure that in litres. Alright, so let's look more closely at the question. I know that it starts at 1,000 litres. That's my constant term. That's because it starts at 1,000, that is not going to change. I also know that the water increases by 2,000 litres per hour. That's giving me a clue to which variable is the one that is going to be the gradient. Right, 2,000 litres per hour. As the hour changes, the number of litres change. So let's fill in my table. So at 0 time, I have 1,000 litres of water. After 1 hour, 2,000 litres flows into the tank, so I now have 3,000. The next hour, another 2,000 flows in, so I'm up to 5,000, 7,000, 9,000, and then finally 11,000 after the 5th hour. So from that, I can now start to define my rule. I know that the top numbers are going up by 1, so that's my run. The bottom numbers are moving by 2,000 litres, so that's my rise. I also have this big clue here. Remember when we were looking at x and y graphs, that when the x value was 0, the constant term was underneath it. So that 1000 is the C part of my rule. So let's have a look at how that would appear on a graph. So if I was going to graph it, at 0 I'm at 1000, at 1 I'm at 3, 2 I'm at 5, then 7, and then 9, and then 11. So this graph does not go through the origin. Let's connect those up. And there I have my graph. Now if I wanted to find the rule from the graph, remember all I need to do is look at 2 points and draw a triangle and work out my rise, 2000, and my run, 1. So my gradient is 2000 over 1, or just 2000. I also wanted to look for my y-intercept. In other words, the vertical intercept. So I know that the constant term is a 1000. So now I know from the table I had looked at previously and this graph that the rule is, it was y equals mx plus c, that's our basic rule, but the volume equals 2000 t plus 1000. So that's my rule. So now I want to use that rule to find some further solutions. So I'm going to start off with the rule. Volume equals 2000 t plus 1000. I'm going to substitute in the 7.5 hours. So this is assuming that the water kept filling up at 2000 litres per hour. That's going to equal 2000 times 7.5 plus 1000, and I'm going to end up with 16,000 litres in my tank. Well, let's look at the second example here. Well, now I want to find out how long it would take for the tank to fill up completely, and it's a 30,000 litre tank. So I start off with my rule again. The volume equals 2000 litres per hour, so 2000 t, plus a starting point of 1000. Now this time the 30,000 is the volume. So, a little bit of algebra. Let's take away 1000 from both sides. That ends up with 29,000 equals 2000 t. We know that if we divide both sides by the same number, we can find our solution. So the answer is that the time it will take will be 14.5 hours. Let's just look at one more example. In this case I'm travelling up the Hume Highway in my truck. I'm travelling at a constant speed, so the assumption there is I'm using a constant amount of fuel as I travel up the highway. I'm beginning with 200 litres of fuel in the tank, and after 2 hours I check the fuel. I only have 150 litres left. I go another few hours, and after 5 hours I've only got 75 litres left in the tank. I want to know how long it's going to take before I run out. Just fix that spelling mistake. Alright, so let's fill in the values. Let's have a look through. Alright, 200 litres to start off with. So at 0 I had 200 litres, and after 2 hours I had 150, and after 5 I had 75 hours. So I wanted to plot that on the graph. 200, now 2 hours is 150, somewhere around there. 5 hours is 75, somewhere like that. Now if I wanted to then take my ruler, which I don't have, but rule a nice straight line as much as I can, it's going to head down somewhere in that direction, but I can't be completely sure. So what I want to do is I want to find a rule that explains exactly where that is heading. So if I go back to the table, take any two pair, So I'm going to look at this first pair. This is moving by 2. This is moving by 50. So my rise over my run is 50 over 2, which is 25. And my constant term is, the clue there is that I'm starting at 200. So my rule is that my volume in the tank is going to equal the gradient. Right, now the gradient was actually going down. Alright, so the gradient is negative 25 T plus 200. Another way of writing that, because we don't often like to start with a negative number if we can avoid it, is we put the 200 at the front and we take 25 T. Now if I wanted to work out how long it would take before I run empty, I would need to make the volume 0. If I made the volume 0 and I add and subtract to both sides, divide both sides by negative 25, I'd find out that it would in fact go all the way down to 8 hours. So after 8 hours, no more fuel. Alright, that's the end.